Hello, everyone. We're going to wait a couple minutes and let some additional people show up, and then we will get started here. Just to let you guys know, I do have it set up so that you're not able to unmute yourselves, just because I don't want to have any sound or anything like that going on in the background. What I would prefer is that we use the chat box. If you would like to ask a question or whatnot. And I will try to keep tabs on that so that I don't lose track of any questions or come up. I'm trying to make sure that I do is get this chat room up, or the chat box up, so that I can see. Here we go. Awesome. Floris, good to see you, man. Or not see you, I guess. See you chat. Gave an awesome presentation a couple days ago. All right. I am holding people in the at the waiting room set up. So this is my first time using the waiting room, so I may end up having some issues, or there may be some people sitting out in there. Can everyone hear me? Give me a yes on the chat box if you can. Cool. Can you also see my screen that says a Passivhaus journey? Perfect. Okay. All right. So a couple housekeeping things to start off. First, thank you everyone for coming. I know there's been a lot of these things popping up lately. So it is time out of your day, out of your afternoon, evening, morning, depending on where you're at. And just want to thank you for that. As such, I'm pretty passionate about a lot of this stuff, and I tend to ramble. So the format is going to be an initial part of the presentation / tour will be focused on the basic principles of Passivhaus. And then I'll have specific pictures and not demonstrations, but I'll have specific pictures and references to our project as they relate to those principles. And then we'll walk through that. If you have any questions, then please type them in the chat box. But since I tend to ramble, since I'm passionate, my goal is to keep this to no more than an hour and a half. So we're going to call 5:30 the end time on this. The first part of it is going to be, like I said, focused on the basics. And then we're going to allow anyone who wants to jump off, who may not be totally, who might not care at all about a lot of the construction details or the construction process. You are free to jump off. You're free to hang on and stay and listen as much as you'd like, but we'll let those people jump off. And then we'll get more into the construction details and kind of the process that I went through. And then we will just kind of go from there. So the first part, that's the principles, a little bit more structured. Second part, not as structured. I'd still have pictures and a lot of that kind of stuff. So like I mentioned, everyone is muted. Okay, so I prefer that you would use the chat box if you have questions as we go along. I will give everyone I'll kind of take some breaks, make sure that there aren't any questions that come up that I skip as we go through the different principles. So please use that chat box. I will be recording this meeting, and at the end of it, we'll have a link. We'll send that out to everyone who is a part of it. If you are not, if you don't have your contact information, I'll have my contact information here on the slides, and feel free to email me or get a hold of me in some fashion or another. We can get you a copy of this. And then we'll be conducting a couple polls as well. So that's something that is new to me, but I want a little bit of interaction from you guys. And my goal would be at the end of this that regardless of whether or not you know anything about Passivhaus, or this is, you know, just another Passivhaus thing that you've seen hundreds and hundreds of, you take something away from it, okay? So let's get into it. So here's our agenda. The audience poll, do a little bit of overview, some of my journey, a lot of the project description. The virtual tour is going to take place more in terms of pictures and such. And then if we need some video, we can. It's kind of clunky following someone around with a, as they walk around somewhere on a camera and they're breathing and going up and down the stairs and shaking all over the place. So we are going to avoid that as much as possible. And yeah, okay, so let's get it kicked off. So audience poll. So I'm gonna give this a shot. And we are going to launch the Let's Get to Know Each Other poll. Okay, so if you're on a computer, this should pop up. Please answer the different questions that I have. I just want to get an idea of where the audience is located, whether or not you are, you know, in Red Lodge, in the state of Montana, somewhere else in the United States, or out of the country. How familiar you are with Passivhaus. What level of interest do you have in the construction details and such, the geeky building science nerdy stuff? And then the other thing is how you are attending the event, whether or not you're on a computer or on a phone. Just because if you're on a phone and you're on video, the polls will take over your screen. At least that's my experience with it. You can always hit the little close button that is at the top of that poll to get back to whatever screen is being shared. And then if you haven't answered the poll, you can click back at the top of that screen where it says that you can enter the poll, and then you can give your answer. Okay, cool. So we've got 37 of 42 that have voted or that have filled things out. We'll give a couple more seconds for some other people. Of 42, you've got 8 more seconds. All right, end the polling. Okay, so we're going to end the polling and let's share the results. So we've got a quarter of the people that are around the Red Lodge area, another 7 or so from somewhere else out in Montana. Half of them are from the United States. Awesome. Couple of people from out of the country. Not sure where, maybe North America or somewhere way cooler than that. And then let's see what we've got for familiarity with Passivhaus. So a quarter don't know. Oh, so everyone's heard of it. That's cool. Very, very cool. What level of interest? Oh, half and half, huh? All right, sounds great. So like I said, the second part of this will be where we get into the details and a lot more of the construction pictures. So feel free to stick around as much as you want. And then most people are on a computer. Okay, those of you on the phone, we've got a couple more polls that'll come up where there'll be pictures. and you may have to bounce back and forth between that picture and the poll to be able to answer it. So just know that when the poll pops up, you can hit the little close button up at the top. That'll take you back to whichever screen is being shared. You can look at that, get your answer, then click back up to the poll. That'll bring it back up, and then you can answer that poll. All right, perfect. Everyone good to go? Sounds good. Okay, so passive house. So here's my analogy for those of you who don't know much about it, or those of you who, you know, have a little bit of knowledge, but aren't 100% sure about what it means. So we got the Coleman cooler that everyone knows about. It's 25 bucks, right? And it does an okay job. It'll keep some ice cold. It's not very well built, but it holds your soda, it holds your drinks, keeps your stuff cold, right? Passive house is Yeti cooler, okay? So concepts are super simple. When you think about the difference between a Coleman cooler and a Yeti cooler, they pretty much look the same. Yeti throws some cool colors in there, but for the most part, they've got a bottom, they have sides, they have a top. What Yeti does, right? They do a fat wall design. So they just put a little bit more insulation around it because that keeps things colder, right? They've got a grid lock gasket and an interlock lid system. All that is so that air doesn't come in, okay? So there's not a whole lot of difference in terms of the technology that the Yeti cooler is using that Coleman doesn't use. It's not like Yeti discovered something that is, you know, amazingly new and are able to exploit that to make the best cooler in the world. No, they just insulate it a little bit more, and then they make it a little bit more airtight, right? That's what passive house is, okay? The great thing is that a passive house does not cost 10 more times than a regular house. And there's a lot of questions that come up in terms of pricing. It can cost as much or as little more than you want it to. You keep the design simple, it's not that much more. If you want a bunch of crazy, you know, angles and you need steel beams, that could cost a lot more. If you're in a climate where it's a lot more warm, or the climate is not near as harsh, not near as expensive, windows are a lot easier. Okay, so the cost thing comes up a lot. Yes, it costs a little bit more in residential, but you can make it cost way more than a regular house, or you can make it cost pretty dang close to a regular house. So, Passive House has 5 principles, and we're going to cover 4 of them relatively in depth with some slides, and that's what the bulk majority of the first part of the presentation will be. So the principles, airtight, right? Just like Yeti made an airtight, they've got their gasket on there. You want to make the structure as airtight as possible, okay? You need lots of insulation, especially in an area like Montana, which is cold, and you heat a lot of the year, so you need a lot of insulation. You need really good windows. Again, in Montana, where we're located, it is cold, and you need really good windows that are airtight and very well thermally performing, such that you are able to keep the home comfortable. Thermal bridge-free construction, you got thermal bridges everywhere. A thermal bridge could be an example of, let's say you need a steel beam in your house for some reason from a structural perspective, and that steel beam is going to be exposed to the exterior. Well, steel's a lot more conductive than wood. You're going to have a lot of heat in your house going through that steel beam very quickly, and the principle is not that you have to eliminate every single thermal bridge that exists in a structure, because that's not possible. It is to make sure that you account for them and then make and then address them if they need to be addressed. Okay. And then the 5th principle is balance ventilation with heat recovery. So we'll walk through each one of those different principles. Now, those are the principles of Passive House. Passive House has a few requirements. There aren't that many requirements for Passive House. So it has to be airtight. That is the one thing that is physically measured. You have to have an airtightness of this 0.6 ACH 50 or less. We'll cover that when we look at the airtight envelope piece of it. And then these rest of these requirements are all determined by the modeling. So you have an extensive energy model where you put in the shape of the house, the type of windows you're using, the type of walls you're using, everything, your different appliances, how you're heating, all of these things. And then that model will then calculate a heating demand, which just means the amount of energy you use for heating throughout the year. You have to be under a certain value. You can't use more than a certain amount of total energy in the house. And then you have this thing called the thermal comfort, which is the comfort criterion, which just means it's addressing the fact that every surface in the envelope has to be above a certain temperature for the most part, so that it is comfortable. And then it also addresses overheating. Yes, it's great. You can get a lot of energy from the sun if the entire south-facing facade of your house is glass that has a high solar heat gain coefficient, but it's probably going to get really hot and uncomfortable in there during the shoulder seasons and during the summer if you're not able to shade it. So that's not very comfortable, and Passive House would not allow that. Okay, so any questions on principles and the requirements for Passive House as we go? No? Okay, great. So, a little bit about myself. I was born and raised in Red Lodge, Montana. Red Lodge, Montana is a small little town in south central Montana. There's about 2,000 people there. I am not a builder by trade. I went to engineering school down in Golden, Colorado, got a mechanical engineering degree, worked for 10 plus years down in Denver as an engineer, and then quit my job and moved back home in 2018 to build this project that we have. I first learned about Passive House in 2015, did a lot of self-learning, took the Certified Passive House Tradesperson training. That's a training that is put on specifically for the construction industry, the people who are actually building these things. So I took that in Denver in May of 2017 from a company called EMU Systems. I'll mention them a little bit more as we go on. And then I started helping my brother with a retrofit of a pole barn that he was fixing up in early 2018. I quit my job in April of 2018, moved back home, broke ground on this project in April of 2018, and my wife and kids moved up a month and a half later, and my full-time job was building the house. So these things that I talk about, I literally, other than some interior walls upstairs, I did everything. I framed my footing, I put together the foundation, we poured concrete, I did all the framing, I did all the air sealing, I did all of the electrical, all of the plumbing, all of the HVAC, everything, all of the window installs. So I've got firsthand knowledge of building a passive house. So we finally moved in November 2019, right? It always takes a lot longer than you think it's going to take, especially when you're doing it yourself and you've never done it before. But even after all of that, I think Passive House is still pretty dang cool. A little bit about our project. So we're located, like I said, in Red Lodge, Montana, South Central Montana, climate zone 6. And a lot of times it comes up with the question about heating degree days. We're 8,250, I think 8,250 heating degree days is what was calculated in the PHPP or the Passivhaus Institute climate data. It is our family home, right? We're 2,500 square feet, give or take, 2-story rectangle. It's not the fanciest looking shape, but I'd never built a house before, so I wanted something that would be relatively easy to do. Our construction for our wall assembly, double stud construction with service cavity. So we've got 15.5-inch thick walls. We'll cover that in a little bit more. In terms of utilities, we are all electric. We do, for our heating, we have super simple electric resistance in-wall fan heaters that anyone could go pick up at Home Depot for $100. That's all we have for our heating. We don't have any cooling whatsoever because it doesn't really get hot here, at least not for too long. So we have no cooling whatsoever. ProClima is a company out of Germany, and they make products that are that would be, you would equate to if you've seen Typar or different tapes or Tyvek or those kind of things. So they make WRBs, they make tapes of all various thicknesses and sizes and everything. So we use mostly their products. Our windows are from a company called SmartWin. Compact is the version or the model of those windows. We'll cover that a little bit more in depth. For our ventilation, we have a Zender 2450 ERV. We'll get into that a little bit more. And then, as I mentioned, 2017, I took the builder training from EMU. And EMU is a company that does a lot of really cool things. One of the things that they were working on, especially at the time that I was taking that training, was developing a pilot system in which they would have standardized construction systems for all different climate zones. And those construction systems would be fully vetted in terms of the building science and the hydrothermal modeling. And they did a ton of virtual prototyping to come up with these construction systems. And they were looking for builder partners. So it ended up being a really good match. And we were the first pilot partner for EMU at the start of the pilot partner program. So that's pretty cool. And I'll go into it a little bit more in terms of what that meant for us in terms of taking the thought process of what kind of wall I'm going to build or how am I supposed to put these things together. That was taken off of my plate because they had already figured that out. So any questions about the house in general? All right, I'm going to do a little. We're going to pull up. Give me a second here to pull up SketchUp model, and we'll show you guys the floor plan a little bit. You can see here it's pretty much just a 2-story house. Some of this wood on the outside may look a little bit strange to people, but that's just a rain screen cladding that you put on so that you can have improved ventilation and such behind your siding. So let's take a look at our house. So everyone, can you guys give me a thumbs up whether or not you can see the SketchUp model? Cool. All right. So I built the whole entire house in SketchUp. So just 3D programming model that you can use for all types of design and such. That's the house right there. From a floor plan perspective, it's just pretty much a standard house, right? So we've got a little mud room here. You walk in, we've got a little half bath. We have a mechanical room. We've got a mostly open floor plan downstairs with the living room the dining room and the kitchen. And then we have stairs leading upstairs that are kind of break up that room. And then this is the south-facing facade right here. It's a pretty standard main floor. And then the second floor, we've got a 8-year-old, my daughter's 8-year-old, my son is almost 6. So we've got my daughter's bedroom, we've got my son's bedroom. We wanted individual bathrooms for each of the kids. So my daughter's got her own private little ensuite. My son's got his bathroom that kind of serves as a main bathroom for upstairs. We have a little sitting area in the south. We got a little study area here. We have laundry. We got a master in the southwest corner, walk-through closet into the master bath. So passive house is pretty much just a normal house. Okay. Any questions on that? Now, one thing to keep in mind as we go through this, especially towards the end, I mentioned our heating. Our heating is just super simple electric resistance heating. So what we have upstairs, we have all little 1,000 watt heaters. Okay, so we have one heater in the master that sits right here. We have one heater in this main kind of upstairs sitting area that sits right here in this wall. We have a heater here in my daughter's room. And then we have a heater here in my son's room. So we have 4 of them upstairs. And then if we go back downstairs, we're big and wide open. We have one little 2,000 watt heater sitting downstairs, kind of by the kitchen area, if you will. Okay, so just keep that in mind of how those are spaced out within the floor plan as we start to come back to it in a couple of the other slides. Okay, any questions about the floor plan or anything? Cool. All right, so back to some polling. So the question is going to be, you have 3 different numbers here. You've got a 1, a 2, and a 3. And I want to know from the audience, air circulation. Great question, Marty. Let's go back real quick to the SketchUp model. Let's find out. Okay, so Marty asked about our ventilation system. So with our system, with a passive house, because it's so airtight, you have to ventilate it. We'll get into that in a little bit more detail. But what you end up doing is you have ports where you supply air and you have ports where you suck air out of the house. So our supply is, all supplies are set up so that they go to living areas. So we have one supply port that sits in the ceiling over the living room. That's it for downstairs. We have exhaust ports that suck air out of the mudroom, out of the half bath, and out of the kitchen. If we go upstairs, we have supply ports in this wall for this bathroom, or sorry, this bedroom. We have a supply port in this wall for this bedroom. We have a supply in the master, in our ceiling. Then we have exhausts in each one of the 3 bathrooms. And we have an exhaust over the laundry area. So good question, Marty. Okay, so back to the polls. So I'm going to show 3 different pictures from the house. Each one of them is going to have a 3 numbers associated with it. I want you to let me know what you think looks strange or out of place in those pictures. All right, so bathroom quiz, we're going to launch it now. Like I said, if you're on a phone and this takes over your screen, you can click the close button. That'll let you see the picture, and you can just click back on to the polling button at the top, and then you can answer that poll. And we got 60% of the people that have already answered. All right, cool. So you're going to end that polling right now. You're going to share some results, and this is, I get a kick out of this. So 65% said, is that an outlet without a faceplate? It is an outlet without a faceplate. That's not what I was going for. The building inspector might not like it, but not what I was shooting for. 20% saying, why in the world would you put a window over a sink? Very good question. We ask ourselves that sometimes. My wife is from Kansas. To the north, it looks like Kansas. To the south, it looks like Montana because we have big mountains. So we wanted to be able to see Kansas and then turn around and see Montana at the same time. And 18% said, is that a UFO on the ceiling? Ding, ding, ding. Your 18% are right. This is just a normal bathroom. This is a passive house that has a normal bathroom. The only thing that even is remotely different about this bathroom is that this port right here is not a bath fan port that you would see maybe sitting over a toilet or something like that. It does the same thing. It's sucking air out of the house, but it does it all the time. It never turns off. It's always running, okay? Next poll. Stop sharing that. All right, here's your kitchen quiz. So this is our kitchen as of this morning, and feel free to answer whichever you think may be the correct answer in terms of what looks out of place. All right, 5 more seconds. We got about 90% of the people that have answered. I was hoping I'd get more 3s too, Mike. All right, end the polling. We're going to share the results. So again, yes, that is an exposed drain plumbing, but it's not a new industrial look. That is just a soffit that I have yet to have built. Why do I have 2 faucets? I only had 2 people ask that. That has nothing to do with Passive House, but number 1, that's that UFO we saw on the ceiling in the bathroom. This one's doing the exact same thing, except it just sucks a little bit more air out than the little UFO in the ceiling of the bathroom. Okay? The one thing that you have to do from a spacing perspective on these things is just make sure that this is not too close to where you're going to be cooking, where you've got a lot of grease and stuff coming up. We do not have an exhaust. We recirculate our venting and our hood over our range. You could exhaust it if you wanted to directly to the outside, but we do not. Right? So this looks like a normal kitchen because it is a normal kitchen, and Passive House is normal. The only thing that is slightly different is the fact that we've got this little UFO looking thing that sits on the ceiling that is sucking air out of the house all the time. So the great thing is that when I burn something in the stove and it smells really bad, all I have to do is boost my ventilation system and it sucks right out. Yes, Stuart Perkin, there's a boost feature. So the boost feature that you have set up with our system runs about 150%, maybe a little bit more than the designed continuous ventilation rate. And our system's pretty simple in that we do not have any sensors that would kick it into boost mode if, say, a CO2 goes up or anything. So we have to manually kick it into boost mode. But yes, there is a boost mode that you can put the system in. All right. last and final, I don't even know how that got on there. Okay, bedroom quiz. You can see here, these windows, these are the mountains that I was talking about that are to the west and to the south of us. That's Montana. You turn around and look out that bathroom window and it's nothing but flat plains, so it looks a lot like Kansas. We don't have the humidity either from Kansas, which is pretty nice. A couple more seconds on the polls. All right. Okay, so 80% of the people asked why that window is open at the top. And yes, it is. That's a tilt and turn window. That doesn't mean it has to be a passive house window. But most high performance windows are of the European hardware variety, meaning they're tilt and turn. So they tilt inwards. They hinge down at the bottom and open up at the top. And then if I were to push that closed and turn the handle down, it would open inward like a door. That is also another face outlet without a faceplate. And then this is some tongue and groove beetle kill pine that we had from Northwest Montana that we put up on the ceiling. So cool. Well, thank you guys very much for taking the polls. And we can move on. So there's a little bit of a tour of the house with those polls. Okay. So let's move into those different principles. So I mentioned we've got an airtight envelope. Airtight envelope just means, so you can do what's called a red line test. Take the section of your building and you put a red marker down, and you have to be able to draw where you want your air barrier, and you cannot pick up that red pin. It has to be continuous all the way around your entire envelope. So for us, this is what it looks like. Our floor, we are on a crawl space foundation. So we decided that our floor, our subfloor, was our air barrier on the floor. So normal subfloor sitting on top of floor joists, but you can see every single seam is taped. Some of the larger holes that we have are also taped, okay? So that's what it looks like on the floor. Now, if you go to the walls where you have a wall meeting a window, you can see this Intello is a product that Proclima sells. It is a smart vapor retarder. Think of it as a really fancy poly on steroids that does things that are much cooler than 6mm poly would. But it keeps all the air from leaving the house. So it is installed on the walls and it attaches directly to my windows. Our windows are not filled in with a little bit of foam from our spray can, Great Stuff spray can, because that is not airtight and is really hard to install really well. Okay. And this is our ceiling and how that meets the wall, right? So we've got our Intello on the wall, it travels up, and we have Intello on the underside of our roof trusses, and that is all connected, okay? You can see we have some framing that sits on the inside of that Intello. That's so we can run a lot of electrical and everything that runs through ventilation, all of that sort of thing, and be able to not have to put many holes whatsoever in our air barrier. The other thing we also have are penetrations that we have, so this is 2 penetrations through the subfloor, you need to make sure that those are sealed. Here we're just using some fancy little gaskets that make it really easy. You could easily tape these pipes, but they go, this is the main water line coming into the house. This is the main drain line, plumbing drain running out of the house. Those are sealed, okay? So I mentioned that the air tightness was the only thing that was measured from the requirements of Passivhaus. Okay, so you measure that by doing a blower door test. And a blower door test measures the leakiness of whichever structure it's hooked up on. Right? It's got this fan right here, fancy little fan. It's got a lot of tubes and stuff hooked to it. The fan blows air into your house and it pressurizes it. So imagine blowing air into a balloon and it blowing up. That's what it's doing whenever you're pressurizing the house. Then it turns around and it tries to suck as much air out of the house as it possibly can. And when it does those two things, it knows you give it the volume of your house, and it can measure the air leakage in a unit called ACH 50, which is just air changes per hour at 50 pascals. It can tell you how leaky it is at a certain pressurization or depressurization value. Okay. So older homes, traditionally an ACH, well above that. The home that we lived in Denver when we lived there was built in the late 80s. I think we were at 12 whenever we had a blower door back in 2010, before I knew anything about any of this stuff. Current Montana building code requires 4 ACH 50. Passivhaus requires 0.6 ACH 50, so 6.5 times tighter than the current Montana building code. That's what Passivhaus requires. Our final blower door that we did, I can't remember when we did it, earlier this year, 0.14 ACH 50. So we were 4 times better than Passivhaus and 28 times better than Montana code. January, thank you. That's when it was, Mariana. So we did our final blower door in January. And great numbers, but I was the one that did all of the install. I was the one that put the holes through the air barrier if they needed to be put through it. But it was just attention to detail in terms of when that was installed to make sure that you think through the process of how do my ceilings attach to my walls, and how do I make that red line when I draw it around my section of my structure, how do I make that continuous? Okay, so that's the airtight principle. Any questions on that? All right, now I said we need to insulate a lot, right? Especially in Montana because it's cold. So 2018 IECC, which is the International Energy Conservation Code for our climate zone, typical walls are 6.5 inches thick. You got a 1/2 inch sheathing, you've got a 5.5 inch wall, you've got a 1/2 inch drywall, right? So the required R values for your different assemblies in the 2018 IECC need an R value of 30. You can see what it is for the wall and the ceiling and the windows. Thing to keep in mind on the floor, the wall, and the ceiling, that is just the nominal R value of whatever insulation you're using. It's not the true calculated R value when you include studs and all of that kind of thing. So what do our walls look like? Our walls are 16.5 inches thick from the inside of the drywall to the outside of the sheathing. We have double stud, and you can see our R values for each one of our assemblies. So almost double the R value of our floor compared to what code would require if we were at the 2018 code. Our wall about 3 times as much, ceiling twice as much, and our windows are roughly 3 times higher performing than what code would be. So what did we do for insulation? In the crawl space, so this is down in the crawl space. These are floor joists for the main floor above us. 14 inches of dense packed cellulose. So we just, we've got our own insulation machine, hung the netting, packed the cellulose in. So that gets us R50, that. For the walls, We have 15.5 inches of mineral wool bats. So right here, you're looking at 13 inches. You're looking at an exterior wall here that's 3.5 inches thick, a 6-inch gap in between those two walls that is also insulated, and then another 3.5-inch interior wall that's insulated. And then you saw back on the, when we talked about air tightness, that Intello material went over the top of, or on the inside of this wall. Then what we ended up doing is also forming another 2.5-inch cavity that was also insulated before we actually put on sheetrock. So that got us to 15.5 inches thick of wall cavity. What did we do in the ceiling? We had 26 or so inches of loose fill cellulose that was blown on top of that Intello material that you saw. And then on the underside of that, in those 2x4s that were running on the bottom underneath that Intello, that 3.5-inch space is also insulated. Let's see. Jessica asked, why did you decide to use mineral wool at the wall cavities? So we use mineral wool because no one around our area does any type of dense packing, whether that be fiberglass or cellulose. One, it's hard to find a contractor that will do that. And two, it's hard to find anyone who's done it at depths of more than 5.5 inches. So we didn't really want our 13-inch cavity to be a test wall for anyone. And I didn't really want to make that my first foray into dense packing walls. So we went with mineral wool because we liked the thermal properties of it. We liked the sound properties of it. We liked the moisture properties of it, the vapor permeability. And it was a prepackaged product that we could buy from Lowe's and have them deliver it to us, and we just installed it. So that's why we went with mineral wool. Okay, cool. So another principle was high performance windows. Okay, so our windows, I mentioned, are a brand called SmartWind, and the model is compact. These are built in Colby, Kansas, which is western Kansas. They are the highest thermally performing window that's ever been built in the United States. The glass came from Niwot, Colorado, and the locking hardware and such all came from Europe, because the typical windows that you would see in normal homes in North America, double hung windows, single hung windows, sliding windows, they don't have the ability to maintain an airtight seal pretty much any time. So these European hardware, or this European hardware that's used with these windows, ensure that airtightness. And then our triple pane glass is what we need from a performance perspective, so that we don't lose too much heat to the outside. And then I mentioned there's that comfort criterion that specifies that you can't have any surface that's below a certain temperature in your room or in your structure. So the triple pane glass helps with that. So said they're nearly 3 times better thermal performance than code windows. And this measurement from the outside face of this window to the inside face is 5 7/8 inches thick. So it's almost 6 inches worth of insulation. Okay, so Aaron asked the question, if we drop the eaves to insulate the cellulose and allow for ventilation. I think if you want to hang on, we'll cover that when we get into more details, but we have a vented attic. So we have small little vents that are in there. Now I've got pictures of that. This kind of furry stuff that you guys see on these windows, this is all wood fiber insulation. So they basically stripped the frame of as much structural wood as possible, or anything that is not structural wood, sorry. And they've replaced it with wood fiber insulation for better thermal performance. So pretty awesome windows. And it's really awesome that you can get windows this good built here in the United States. All right, so lastly, we have our ventilation system. Okay, so this is the Zender Q450 ERV, fancy sounding, but this is the lungs of the house. When you build a house that is so airtight that is 0.14 ACH50 or even 0.6 ACH50, even 1 ACH50, you start to get tighter and tighter. You have to be able to ventilate that, because if you don't, you're going to have issues from a moisture perspective, because everyone lives inside and most people take showers inside and most people cook inside and most people breathe when they're inside. And when you do all those things, you release a lot of moisture. And if you have a house that is really, really airtight, that moisture isn't going to go anywhere. And a normal leaky house, it just naturally leaks out and is replaced by less dry air from the outside. So we need a ventilation system. So the Q450 are the lungs of our house. We suck, there are 2 fans in this white box. One fan sucks air into the house all of the time, and the other fan on this side is always blowing air out of the house, and they're balanced. They run 24/7, and our design rate is a little over 100 CFM. To give you a perspective, most bath fans that you will buy are usually at 80 or 110 CFM. So our continuous ventilation runs at about the same CFM rating as a larger bathroom fan. Okay, and the box on the right, Andy, the box on the right is our geothermal preheat. So if you want to stick around, I'll loosely cover it here in a second, but we can talk about that a little bit more in detail if you want to stick around afterwards. How noisy is it? It is silent. Can you guys see my video? Because I can't see myself. That's the only thing. Let me see here. Yeah. Stop share. Okay. So, hello everyone. You guys look great. Okay, so here's my video. Never mind the fact that it's not covered up yet. There's a ladder there. I've got a lot of construction still left to do, but that's that box right back there. You can't hear it. You can hear it a tiny bit when it's on boost mode, but other than that, it's silent. All right, let's get back to this. I'll explain to you guys a little bit what this thing does. Share. Cool. All right. So, like I said, it runs 24/7. It only uses 28 watts of energy, which is about 6 cents a day for us. It recovers heat from the inside air that's inside this house that we're blowing outside. It grabs that heat before we blow it outside. I'll walk you through how it does that. Let me pull the chat window back up to make sure that I don't lose track of that chat. Sorry, guys. Okay, cool. Cool. All right, so here's an example where this duct right here, it is insulated now, but in this picture it wasn't. So this duct, let's say in the winter, we had 9-degree air coming inside, okay? So 9-degree air was coming in from outside. It goes through this box, which has a little pump in it, has some tubes that are buried underneath the ground. We steal the ground's heat to preheat this really cold incoming air. So we come in at 9 degrees, it goes across this little heat exchanger that's in this box and leaves that box at 34 degrees. Okay, so we had about 25 or so degrees of heating just from using the 50-degree temperature that is, 5 or 6 foot underground. That thing only uses 37 watts or so, this box right here, okay? So we've got 34-degree air. Now we're into the lungs. We've got that 34-degree air comes into this port. Okay? This port right here is supplying air. to the inside. So those are those supply ports that sit in each one of the bedrooms and down in the living room. That temperature of that air is 65 degrees. How do we go from 34 degrees to 65 degrees? Because we've got their other fan that's always sucking air out of the house. And inside the house, it's 71 degrees. So I'm taking the temperature from the 71 degrees and I'm passing it next to, not in the same, the air streams never touch each other, but they go through a heat exchanger inside of this box, such that my 71 degree air warms up my 34 degree air to 65 degrees. And then when that 71 degree air gets blown outside, it's 48 degrees. So it's pretty cool. So we are able to, with using 37 watts of our preheat and 28 watts of this thing running, so that's what, 65 watts? We're able to take 9 degree air from outside and heat it to 65 degrees using 65 watts of energy, right? We're just using the heat that is generated from inside the house to do most of the heating for all of the air that's coming into the house. So pretty cool stuff. Any questions with that? Okay, cool. So I'm only 14 minutes over. No, I'm only 11 minutes over from the 45 that I thought. That's pretty good for me. Okay, so what's it like? What's it like living in a passive house? For the most part, for the 6 months that we've lived here, pretty much like living in a normal house because we have bedrooms and bathrooms and a kitchen, but it's incredibly comfortable. So we moved in, like I said, mid-November. It was relatively cold here in Red Lodge. We had a pretty harsh, cold October. November wasn't too bad. December wasn't too bad. It actually never got super, super cold here. But the house is really, really comfortable. And it's not one of those things that we can say, oh, you know, I think it's comfortable. No, we've got the information that proves that it's comfortable. So our temperatures inside, outside, or not inside and outside, in the different rooms. So remember when I said, make sure you pay attention on the floor plan where we had each one of those heaters. Each one of those heaters has a specific thermostat that controls that heater. That thermostat also measures, besides temperature, it measures relative humidity, and it measures the amount of energy that is used by that thermostat. So this first picture is just a screenshot of the app that the thermostat company has. And you can see I snapped this at 11 o'clock this morning. So each one of those bedrooms and each one of those rooms was no more than 2 degrees difference from each other. And their humidities all pretty much the exact same. That's really cool. Think of how many homes that you've lived in, or how many, maybe your home that you live in now. I know our house in Colorado, it's like the basement was awesome to hang out in during the summer because it was really hot upstairs, but you didn't really go down into the basement in the winter because it was freezing cold. Right here, the temperatures are the same. And it's like that no matter when you take the picture, we see that same really tight temperature profile across all of the rooms. This other picture here is showing the temperature and the humidity from that airstream, here that we were sucking outside. Okay, so that's what this graph is showing. So you can see over the last month, the minimum that airstream has been is 67 degrees, and it got up to 77 a couple days ago, a little bit warm. We had a couple sunny days in a row, and we didn't really open the windows, so we got a little bit warm here. And then you can see relative humidities here as well, right? So for the last month, our temperatures inside have really not swung more than 10 degrees, and we haven't ever heated anything, which leads me to this. So cost of heating, incredibly low. So here are the heating, the amount of money and the energy that we use to heat in the 5 months or so that we've been in the house. So December, 18 bucks. January was a little under 24. The only reason we have some heating in April is because we left the windows open one night and a heater kicked on, and my wife jumped up really quick to turn it off because we didn't want to use any electricity for heating in April, just to say we didn't. So super low energy use for heating. And then our overall energy use is pretty dang low too. So January was the highest that we had. So like I said, everything that we have is electric. We have electric hot water heater. We have electric appliances for like electric stove and range. So this 700 and these values here are inclusive of this heating. So what we're seeing is we probably have about 420 to 470 kilowatt hours a month that we're using that do not pertain to space heating. This right here is just a picture of the app that I have. We've got an energy monitor. So I know exactly how much energy that I've used to the day. I took it this afternoon, so we were just shy of 370 kilowatt hours for the month. So we'll be able to track all of this as we go on. But to give you a perspective, we lived in some rental houses while we were building the house. January 2019 and February 2019, we were at a place on the golf course, relatively big house, had natural gas, hot water heating, natural gas, radiant heating. In January, if you would have converted the gas that was used in therms to kilowatt hours, we would have been, in both January and February, we were right at about 7,000 kilowatt hours. Like I said, it was a relatively big house. We lived in some smaller houses in October of 2018 and October of 2019, and those houses were 1,100 and 1,500 kilowatt hours is what we used in October, and for both of those. And you asked, are you considering adding solar panels? Yes, most definitely we will. It's cool to be in here and have a little bit of an idea of how much energy we think we're going to use. I think we'll be able to fully offset all of our energy use with a 4 kilowatt system. Okay, so that's also something that can come into play too when the price and the cost of you know, you need really big window, or you need windows, you need a lot of insulation, all of that kind of thing. Doesn't that cost more? Yes, it does cost more. But you have lower heating bills, right? Which aren't going to pay for all of that additional cost, or it's not going to pay itself off right away, right? But the size of my solar system that we'll need is tiny compared to other 2,500 square foot houses. So if your goal would be to, you know, go net zero or offset as much energy usage as you possibly can with a PV system, then you would be doing nothing. Like, all we're doing is trading money between, okay, if I don't put in as much insulation, if I don't put in as good of windows, I'm going to use a lot more energy. And if my goal is to offset all of that, I'm going to have to buy a lot more solar panels. Oh, by the way, I'm also going to be a lot less comfortable inside because I'm going to have heat leaving the house a lot more through the junkier windows and through walls that aren't insulated, or a house that isn't super airtight. So that's a good question, Ann. Yes, we will most definitely be adding solar panels. Okay, I'm almost 20 minutes over the 45 minutes that I had allotted myself. What questions does anyone have right now? And if you are part of that group that does not really care about diving into some of the construction details and such, you are more than welcome to drop off at this point in time. All right, do we want to roll into some more of the construction details? Or does anyone else have any questions that they may want to have answered? Cool. Okay. We're going to roll into it. There we go. There's the contact information. I'll leave that up. So I'm on Instagram at Beartooth Passivhaus is the handle. And then email right now is just beartoothpassivehouse@gmail.com. So we'll give you guys a couple seconds to write that down if you want. Like I said, if you weren't registered for the Zoom meeting, send me your contact info and we can get you a link to this presentation. All right. B. Lee asks, how did the SmartWin window cost investment compare with fiberglass windows, other quality window brands? Definitely more expensive. It's hard to say because we didn't really price out other windows. But typically when you look at the cost of triple pane passive house suitable windows for our climate zone, you're probably looking somewhere in the ballpark range of $75 to $100 a square foot. So they're pretty expensive. Now you can make that a lot less expensive if you decide to cut down on how many windows are operable. You can cut it down if you end up having, you don't want like 4 different windows all molded together so they look like one big window with individual sashes. That costs a lot more too, but definitely much more expensive. I really don't know what the cost per square foot of a fiberglass window is, but the comparison between the two in both performance and look and feel is not even remotely close. It's like, you know, buying a little scooter versus buying a BMW. Cool. All right. So if there aren't any other questions, what I'm going to jump into here real quick is I'm going to show a quick version of, okay, can we do this? Okay, I can zoom this way. Okay, so the people who are interested in our assemblies, and I can walk through this a little bit more, okay? Also, okay, so like I mentioned, standard footer, standard ICF stem wall. I did all the concrete work myself. I had never done concrete work before. So I'll show some pictures of the foundation. I used ICF because I wanted to be able to stack the blocks myself and pour it myself, and I just wanted to do it. There was no requirement that I needed ICFs. This crawl space is unconditioned, so there's no real requirement that, you know, we have to make sure that it stays warm or anything like that. I used ICF because I wanted to play around with it because I had never done it before. Now, if we move up, we just have our standard TGAI floor trusses set on our stem wall. They are 14 inches thick or 14 inches tall. And then we just have a 3/4 inch subfloor sitting on top of that. Now my air barrier, like I showed in those pictures, the air barrier on the bottom portion of the envelope is that is the subfloor. So when we went to install and we picked our flooring, which was a wood floor, we floated it. You could glue it if you wanted to. I didn't feel super comfortable about putting down a wood floor and nailing it down by putting thousands of nails through my subfloor. So we just floated it. So that's something that you would definitely have to think about in your whole design process. What kind of flooring do you want? What's your application going to be with that? I'm not saying that you couldn't nail it down. I just didn't really want to put a bunch of holes through it and risk that causing us an issue. All right, so then if you move up, like I showed on the pictures, we had double stud wall. We were just 2x4, 16-inch on center. We had 7/16" sheathing. We were all mineral wool insulation, so that 2x4 plus a 6-inch glat plus another 2x4 got us 13 inches. Then we had that Intello air barrier material that sat on the inside of that interior wall. And then we had a 2.5-inch service cavity that we framed horizontally. If I was going to do it again, I would consider heavily not having a 2.5-inch horizontal cavity. I would consider taking this wall right here and moving it an inch inward and then framing my service cavity with a 2x4-inch wall, just normally like you would any other 2x4 wall. Because then you would have vertical studs when it comes to installing cabinets, when it comes to installing a microwave or a television, mounting that on the wall. When it comes to installing drywall and stuff, just the vertical wall framing is something that is really easy and people are used to. I also probably, if I had to do it again, I wouldn't build 2x4 exterior structural wall. I'd build a 2x6 wall just because it gives you, from a bearing perspective, it gives you more room for weight. We've got a lot of snow up here. It's just a little bit stronger. Okay, so now if we move up, this is really in our construction system, this transition for our air barrier out and around the floor joist is probably the most, and it's not even complicated, but you had to think through it. You just couldn't address it afterwards. Because our exterior wall was structural, our floor joist for our second floor system had to sit on that wall. And because our air barrier needed to be continuous, we had to figure out, how do you take that air barrier from the inside of the first floor wall and get it to the inside of the second floor wall without ever having that thing interrupted. All right, so I'll show some pictures of that, but that's a detail that you definitely have to think through. And I wouldn't say that it's hard. I would suggest I might do it slightly differently, and when we get to those pictures, I can explain what that might be. But it wasn't an overly hard detail to achieve. Then we go up to our second wall, or our second floor walls, exact same as our first floor walls, just double stud. And then we've got a engineered roof truss that is sitting on top of those walls. Our air barrier wraps on the bottom of those scissor trusses. And then we have 2x4s that are installed perpendicular to the roof trusses to form that service cavity that we can run all of our ventilation and such in. Okay, and Aaron asked about venting. So we've got a 24-inch raised energy heel on our trusses. And then I'll show some pictures of what that venting looks like as we get a little bit further. So any questions on that overall look? Some people had asked, why double stud? So there's as many ways that you can dream up to build a fat, big, thick wall that is higher performing. Like, however you want to dream it up, you can do it. And I don't think there's any one right way. There's trade-offs one way or the other. So double stud for us was really easy because, like I said, we were partnered with EMU. That's their construction system for Climate Zone 6. So I didn't have to think about it anymore, which was awesome. I just said, okay, how do we do this? Now, the pros of double stud, what I like is all of your insulation that you have is sitting on the inside of your sheathing, which I think helps protect it more than if you have exterior insulation. I like the fact that if you were a contractor and you were wanting to put up houses relatively quick, you could do it because you get a framing crew to build you a 2x6 structural wall and do the framing for the entire house, and then they can piece out And then maybe your more specialized crew, if you do stuff in-house, can come in and build that interior wall and do any of the additional, more intricate type framing that the double stud might require. I like double stud because it keeps that air barrier really accessible up until the point that you put drywall in. Whereas if you do a continuous insulation on the exterior, and let's say you use your sheeting or your plywood, or you put a membrane over that sheeting or plywood as your air barrier, as soon as you sandwich that or cover that with your exterior insulation, it's really hard to have any access to it. And the transitions are a little bit more intricate between floors. So like for us, we can just set a wall directly on a floor, and my transition from my floor to my wall is super easy because I just go across here and I come up my wall, right? I can take and all of my services and everything can sit and be maintained right in this service cavity. And if I do have any penetrations through there, they can be a little bit more thought out, to where, let's say I'm doing exterior insulation and I have my sheathing here, and I put this wall down, and then I need to drill a hole for some plumbing that goes through this bottom plate. Well, now if I haven't really thought about how I'm going to seal that hole very well, I could be running into some issues at that point. But there are countless ways to build the wall. All of them can perform well. The most important thing is that you find someone who knows what they're doing from a modeling perspective and models it using the correct climate data, using all of the correct indoor, outdoor settings, understands how to run that system or that software, and model it to make sure that it's okay and that it works. That's the most important thing in my perspective. I had a couple questions. Why not have the 2 stories sealed independently? Philip, that'd be super hard, especially because we've got, you have a big open staircase that runs between the 2, so that'd be really hard. How do you secure the perpendicular 2x4s to the bottom of the wood trusses? Derek, I use 6-inch, they were not GRK screws. The local hardware store carries big fasteners by a company called Big Timber, and they had 6-inch structural screws that I used to attach those. Okay, cool. Any questions on that right now before I dive into some pictures? All right. So, okay, foundation. I'm going to walk through these relatively quick. Let me know if you have any questions. Pop it up. I'll keep my eye on this chat box. Okay, so foundation, like I said, I wanted to do all the work myself. I don't have forms. I use this product called Fastfoot. It's just a fabric, a polyethylene reinforced fabric that you can put down. These are all 2x4s that I use to frame everything, so I could reuse those 2x4s in all my framing of the wall. But this is just essentially a bag that we poured the concrete into. You can see this is after we poured it. The bag just kind of puffs out a little bit, and we got vertical rebar to attach. We ended up having a stem wall that sits in the crawl space just to support the floor joists. Okay, so here's something, I mentioned that geothermal preheat in the ventilation piece of it. That was that gray box. And I mentioned that it was connected to tubes that were buried in the ground. So these are these tubes. Those are these tubes. We buried 300 foot of 1-inch PEX that went around the foundation. And then we had a big trench that we dug like 75 feet or so out into the field. Sorry, excuse me, out into the field. So these tubes end up connecting to that box. That box has a pump in it. Whenever the white box senses that the temperature from the outside air is cold and it could be warmed up, it kicks that circulation pump on, and that circulation pump then circulates glycol through these tubes, and we just use the heat of the ground, probably 45 or 50 degrees, to heat up the incoming air. So that was something that, you know, you had to lay all of this line, and then we pressure tested it, and then you cover it up, and you just keep your fingers crossed that hope to God you didn't hit it with a giant rock or something like that and put a hole in it. Because if you pressure test it after you cover everything up and it doesn't pressure test, that sucks. But we didn't have that happen to us. Here's the foundation just with the block laid before we poured it. Like I said, we just use ICFs. It's just a rectangle, so that makes things nice and easy. So that was the foundation part. Any questions on that? Cool. So some framing. So this is just a picture of we balloon framed the gable end walls on the upstairs floor, and I was really high up on the man lift. I just got in the man lift and was kind of scared when I was up this high, but it was a cool picture. Okay, so framing. How did I go about some of that? So the first thing I did is when I was still down in Colorado, I built mock-ups of the wall systems. And I did that both with a company called Siga, and then, like I mentioned, Proclima. So these are Siga products. These are Proclima products. The companies are awesome. Reach out to them. They sent me all of this stuff for free to be able to try out. And one, it gave me an idea of, okay, how am I going to somewhat frame this thing when it comes to windows? But two, what do these products feel like? What does the tape feel like? How does it stretch? How sticky is it? All of those kind of things that I played around with well before we ever moved up and before I ever did anything else. So if you guys want some of these products, most of these companies you can go on, you can get little sample packs either for free or for really low cost. They'll send them out to you. And there is like, if you compare Solitex Mento or Siga MyVest to Tyvek, it's not even a comparison. They're hands down way better products. They perform better. They're more durable. Yes, they cost a little bit more, but not a ton more. From a tape perspective, the tapes are amazing. Both companies' tapes are amazing. So from a framing perspective, I built myself mock-ups. I never built a house before, like I said. I built everything in SketchUp. I modeled every single framing member so that I could think through virtually building the thing before I got on site, and then realized I screwed something up and it was going to be a lot of work to fix it. So I built everything virtually. So framing to the main floor, like I mentioned, we've got a stem wall here. The nice thing with not having the crawl space be conditioned and be part of the air barrier is that I didn't have to worry about transitioning out and around my floor joists and air sealing my crawl space. So that was really, really nice. That's after we set the floor joists, because we're making sure that poly is completely lining the walls and the floor of this. We got poly that we ran underneath that pony wall before we attached it to the footing. We ran small strips of poly that attached to the top of the stem wall before we ever set our floor trusses, because that would be a lot easier without floor trusses in the way. Crawl space access mic, yes, but from the exterior. And I think I might have a picture somewhere along that'll show that. Okay. Main floor framing, like I said, easy. Put trusses on top of the stem wall and put subfloor on top of it. So that was pretty easy. Cool. All right. First floor walls. So what I did is we framed everything on the flat, and we framed just the exterior walls. So we framed them, we sheeted them, we put the WRB on, and then we put a decent chunk of rain screen on, and then we lifted the walls. You can see here's some interior walls that are lifted. The WRB is already applied. Here's a wall that we're going to lift. We've got a decent chunk of the rain screen on. We have the WRB on, and then we'll lift that up. And then there's a picture of all the walls lifted up. Fragment. Okay, so that's our first floor. Mike, there you go. There's the crawl space access right in there. I made it big enough that I could get into it, but not big enough that I could fit a bunch of junk down in there, so it would just fill up. So that was my thought process with that. Our pressure tank for our well sits down there too, so I just had to make sure that it was big enough to fit the pressure tank in, but I can't fit anything really big in there, which hopefully will stop me from storing a bunch of junk in it. Okay, so I mentioned on the air barrier stuff that the trickiest transition for us was taking the air barrier from the first floor walls to the second floor walls, and we had to do that out and around the floor joists because our exterior wall was structural. So this is the main floor wall. This is the beam pocket that we had built that is that will accept one of the big 7-inch wide by 18-inch tall laminated LVL beams that carry the second floor wall. Okay. Now I know that when I get to it, I've got to get my air barrier from inside, and I've got to get it out and around, back up. What I didn't really account for is like that's really tricky, figuring out how you keep a beam sitting on here really, really airtight. Okay. It wasn't hard when you thought about it, but had I thought about it a little bit more in advance, it would have been less stressful whenever I did it. So here's both of those beams sitting in that little pocket. And you can see I made myself a little boat with some tape and some of this Intello. And I fashioned my boat so that it would sit around the end of that beam before I ever picked it up. Okay, so just think through if you have projects where you have an exterior wall that is structural and you've got things sitting on it or kind of sitting on it, but also that break it up a little bit, like we had a beam pocket. Those aren't easy transitions to get out and around, so think through it before you ever do it, and maybe make a mock-up and figure out how you might get your air barrier out and around it, because that could be pretty tricky for you. Okay, so because we had to get our air barrier out and around, before we set our second floor trusses, we put a strip of Intello, our air barrier membrane, on the top of that exterior wall. 475 likes to term this the floppy, think like the floppy sheet or something like that. So you put this on there. We ended up we put our headers for our upstairs, or I mean our downstairs big windows, we put those in the floor system. So those are just the headers sitting on top of that Intello strip. And then here you can see the Intello strip back here. You can see it right here. You can see all of our floor joists set. Okay, there's a lot going on in this picture here. So we've got that floppy piece right here that is sitting on top of that wall before I put my rim board on. I've got a header here because I got a pretty big wall, or big window that's sitting on my gable end. I've got my other floppy piece right here that was on top of the wall before I put the header for my windows on. These two I had to connect and make sure floppy bit. Thanks, Flores. That's what it was. These two have to connect, so I got to make sure that that is taped and set well before I put anything on top of it. And then here's my little beam pocket and my beam and my little boat that I made. And I need to make sure that it is continuous from this little floppy bit to connect to there, and then go around my beam and then do the same thing on the other side. That's the second floor system after it's on. Now, so we're still in this detail here where we're getting out and around. So we laid that floppy bit of Intello on top of the wall, then we put our second floor system in. Well, we hung it over like an inch or two. And then all we did was tape that to the rim board. rim board's 1 1/8 inch thick, it's airtight. So we use the rim board to carry as our air barrier to carry it up around my ends of my floor joist. So you can see here, the corner's taped, the joints of the rim board are taped. Here's the beam, the end of one of those beams, it's taped, okay? And then I'm standing on top of that second floor system. And now that subfloor is taped to the top of this rim board. In this picture, that tape isn't in place. And then every single one of my seams that I have are taped 18 inches, 2 foot in or so, because I'm gonna be setting my second floor wall on here, and I have to connect this to my interior of my second floor wall. And I need to make sure that that is all continuous. Then I frame my second floor walls. Like I said, here, the orientation of the rain screen changes solely because we've got a orientation change in siding material. There's a gable end wall, balloon framed there. And we left the wall. We put our floor or our roof trusses on. That was a pretty quick transition. For the roof, we just have a regular vented roof. So I've got my ridge vent right here. Aaron, here are some, I think, actually, I'm gonna step back a couple. Okay, so we've got a vented attic, right? So all my air is coming out of this little gap here in my ridge vent. We've got a rain screen. So we've got, once we get siding on here, you're gonna have hot air coming up the backside of your siding. And there are, I think, different interpretations of what is the best practice. I don't think anyone knows the right answer, but what we chose to do was we chose to install the WRB, which is airtight, on the underside of the trusses. So we put that here so that this air that is warm, that's going to be coming up the backside of our siding, does not go directly into our attic to vent it. And the reason we did that was because in the winter, I didn't feel comfortable with having warm air come up the rain screen and go directly into the attic. So that warm air would be hitting the underside of this sheathing right here, which could cause some ice dams that you see in a lot of older homes, but they're there because there's no insulation right here, and it's really, the air tightness is really bad. So you got a lot of hot air from inside going up and warming that up. So what we ended up doing is we ended up wrapping that WRB on the underside of the eaves as far as we possibly could. And then our intake for our air that is going up to vent the attic is right out here. Now, I don't have temperature sensors in there. I'm never going to put temperature sensors in there. So I don't know if it makes a difference or not. I've never seen anyone where someone actually measured that, whether or not it makes a difference. But that was a detail that we decided to go with, and I felt more comfortable with it. A little bit more work, but it wasn't too bad. All right, wiring experience. So you can use this Mento product on the underside. You can use it for your underlayment for your roof. And we did that, and it is really windy here. And I looked up one day, and this thing was just flapping like crazy in the wind, and that underlayment had come off. If I were to do it again, I'd seriously think about a self-adhered roof underlayment, because that wouldn't happen, especially where we're at. If you're somewhere where it's not really windy, it's probably not that big of a deal. The cost is probably quadruple for self-adhered versus your traditional underlayment. Yeah, Derek, you can use Adhero, which is basically, I think, Tescon Vanna, just really big. There are a number of decent self-adhered, highly vapor permeable membranes that are out there, but I would seriously think about using self-adhered if I did it again. So that's a big learning that I took away. Here is a picture kind of after the fact. You can see this pillowing when it was kind of windy, and we stapled some string in the middle of those joints because we had learned some stuff from Steve Basic. He had shot me some information of what he had seen done out in Cape Cod by contractors when things got really windy. So it was awesome to be able to pull on that knowledge. Derek, yes, we did run it vertically. We checked with 475. They were perfectly fine with it as long as the overlap between the two were sufficient. And we did it because it was way easier to do that than to roll it out horizontally. This ridge is like 30, almost 30 foot off the ground. So we decided to run it vertically instead of horizontally. Okay, so it is 5:36. I said I'd stick to an hour and a half, so I'm 6 minutes over. My proposal is that if people are interested in this, I have absolutely, I would be absolutely more than willing to, in maybe a week or so, schedule another one of these things, and then we can dive into, continue to dive into the details, because I don't want to keep people any longer than they need to be kept and that they have already. But if people are interested in it, I'm more than willing to show the framing of the double stud walls. We've got some window install. We've got insulation. We have air sealing. We have ventilation. Who wants to see? Because there were some requests. And I will cover it because I know Chris Byers was interested in it. Who would want to see what we did for the wood stove? Because that's something that people sometimes will automatically write off, and I can cover that if people don't want to jump back in or stick around. Okay, Mike says do another one. Derek says completely agree. Interested here, absolutely. Wood stove details, Greg. All right, okay, so here's what we'll plan. If anyone wants to jump off, more than willing to jump off. All I'm gonna cover is the wood stove, but I will cover the wood stove again in the second installment of this. So let's jump back real quick so that if there were some people who did not register and I don't have their contact information, okay, so here's my contact info. Instagram, you can reach out at Beartooth Passivhaus. Shoot me a message, leave a reply, whatever. I can get your contact information that way. Or beartoothpassivehouse@gmail.com. Shoot me an email, tell me you're interested, say that I don't have your contact information, and then I'll include you on the next one. And we'll set that up in the next week or two. Sound good? Okay. All right, cool. So Greg, just for you, and I don't know if Chris is on, but we can look at the wood stove. Let's see here. All right, so wood stove. All right, you guys can still see the presentation screen, right? Cool. Actually, no, maybe not. Sure, there we go. Now I think you can see it. I'm gonna pull up the chat again. Okay, Cool, so wood stove. So our wood stove, let's bounce back here real quick. Our wood stove sits downstairs. So here's downstairs floor plan. Our wood stove sits right here. Okay, so that means that that wood stove has to, the chimney has to go up, and it's not drawn on here, but we've got a chase right here in the corner. Okay, so keep that in mind. Okay, so wood stove. We got a wood stove by Hearthstone. They're a company out of Vermont. They make, high efficient wood stoves. They have an exterior combustion setup for that. So the house is so airtight, you can't run a regular wood stove like you would a regular fireplace, where the air that it gets for making the fire comes from the inside because it's too airtight. We actually have that in my brother's pole barn retrofit. They kept the old wood stove that was there and had been there forever, and it was huge. And that's their primary source of heating, which is great in the winter. But as soon as they kick their bath fan on, they don't have any makeup air. So they just make sure they don't kick their bath fan on while they've got a fire, because it sucks a bunch of smoke into the house. So you need to make sure that whatever wood stove you get has a kit that has exterior combustion air, and a lot of the higher performing ones do. I want to say this wood stove was, I think it was like $1,700 or something like that. So, I mean, you can spend $4 grand on some really fancy ones from Europe. So this one wasn't that expensive. It's pretty small. It's a tiny little guy. I mean, it's a cute little guy. But North American stoves tend to have slightly bigger fireboxes, so you end up not needing to cut your logs down into like 8-inch lengths, like some of the smaller fireplaces. I know a lot of the European fireplace boxes are a lot smaller. So that's our wood stove. Okay, that's approximately where we sat. You can see back behind it, this is some of that horizontal surface cavity. So this is insulated. If we need to, we can run electrical through it, and then you got sheetrock on the outside of it. Okay, so first thing they do whenever they install the wood stove is they put in this little box. And what this box is connected to this framing, which sits on our second floor system. And this is basically what carries the entire weight of your chimney. Okay, so they put this box in, and what they're going to do is they're going to take their chimney pipe, which is, I forgot all of the class A, maybe, I can't remember. It's big, thick, expensive silver chimney pipe. And that will be on the top of this, and it will run from right here. So this is the ceiling of the first floor, and it will run all the way across the second floor, through the roof, up as high as it needs to go outside. Okay, and then below that will be double wall stovepipe. Okay, so they put this box in. Now, here's your chimney pipe, and here is the piece that they put at the end of the chimney pipe that sticks out of the end of that box. Okay, so details that I'm giving you are, there may be, technically, there could be some, I think there could be arguments that could be made that, well, what you're doing is taking away the UTL rating from these things. But talking to people, exploring the different options that are out there, I don't feel that it's unsafe whatsoever. Okay, so knowing that this is our transition from this little black piece into the end of our chimney pipe, I've got to make sure that before I ever put that thing in there, that we're nice and airtight, that this joint right here is airtight. So we sealed that with the same exact sealant that the stove manufacturer gives you for attaching the exterior makeup air. So it is sitting against material that I would argue is just as hot as this junction right here from a temperature perspective. Okay, so we sealed that before we dropped it down into that box. You can see a little bit of that sealant. They hit it pretty heavy for me. Okay, so I know that that joint now is airtight. And now I've got my chimney pipe coming up. So this is the second floor. This is my chimney pipe that is coming up from this guy. And this is the roof. So I'm going through the roof, and I'm going through my air barrier here. So you've got to maintain, you know, what is it, 1 inch clearance to all combustible materials with your chimney pipe. Okay, so the way that we did that is we cut our Intello, and then we put cement board. I've seen people use metal, just sheet metal before, but we use cement board. So we put cement board. Cement board's non-combustible. You don't have to worry about that 1 inch tolerance. That's my interpretation of it. Some people may know more than I do. But with non-combustible material, you can be right up next to it. So we've got cement board here, and then I've put another piece of cement board over here too. And I'm insulated up right against this with non-combustible mineral wool. Now, I just put this on there. If you, this chimney company, I think Excel was the brand of the chimney. They make a sleeve that you can use for insulating and maintaining an air barrier, a consistent air barrier across this chimney pipe. And the guys, the company that did the install for me for the chimney brought that out, and it is literally nothing other than a metal tube with mineral wool in it. That's all it is. Yes, it's their product. Yes, technically you probably should put that in there, but just know that those things exist, and there are chimney companies that make products specifically for being able to keep an airtight junction around a chimney and keep everything insulated. Okay. All right, so now this is the same view of, we're looking up now. This was one of those sheets of cement board. Here's my other one. Here is my tape from the cement board to the Intello, right? So I'm maintaining my 2 inch clearance to combustible materials. And this is 500 Fahrenheit high temperature silicone that I felt comfortable with putting directly next to the chimney and attaching it to the cement board. So some of these details, depending on where you're at, you may have a lot of pushback, or you may have to do something from an inspection perspective. We live out in the country, and in Montana, they don't really care if you blow up your house as long as you don't really live next to anyone else. So we didn't have to worry about that. So that's a caveat that I'm fully aware of. Okay, so that is our seal from our sealing air barrier to our chimney. This is the next piece of chimney pipe that's underneath there. Did the exact same thing, but high temperature sealant around that. Okay. Any questions on any of this? And feel free to say this looks kind of redneck and it would never pass. But I'm just sharing with you guys what we did. Okay, so that was the chimney. So now I am perfectly fine and perfectly content knowing that from the time that the chimney enters my ceiling of my first floor to when it goes through my air barrier on my ceiling, I am airtight. Now this is the makeup air, or the combustion air, that hooks into the back of the stove. So this flex duct hooks directly into the back of the stove. You buy this $30 little piece of metal that They put on they attach directly to the back of the stove. And how do they seal that? They seal it with high temperature black, like 500 Fahrenheit silicone. That's what the manufacturer sends, and that is their installation instruction for air sealing that little piece of metal that has a hole in it. So that's when I say I've got this red stuff that is the exact same thing, that is not black. I'm perfectly fine doing this and not worried about anything bad happening, because the manufacturer recommends and sends the exact same stuff to connect their little metal piece to the back of this stove. So I've got this flex duct that then runs down through my first floor. This is air. This is sealed here. It's sealed on the underside of the subfloor as well, and it runs down in the crawl space, goes out through a pipe in the foundation wall, and that's where all of my combustion air is coming from for the stove, so it can burn a fire. So I have to make sure that where this pipe connects to that combustion, that exterior combustion air, that is sealed. And then I have to make sure that this pipe is sealed to my subfloor, because of my subfloor being my main air barrier on the bottom. Greg, let's see, relative to your electric heating bills, how much did you use the wood stove? We only used it when it was really cold. We definitely would not have had to use it to make sure that things were warm. But it definitely, if we would run it for, call it 4 or 5 hours, not super hot, but we would just kind of run it, load a couple logs whenever it needed it. Downstairs would get to 74 degrees, 75 degrees. It'd be pretty warm. And it would definitely delay or make up for the heating that the electric heaters would have been. So that's a good point on those heating bills. We probably ran, I mean, I don't even know from the amount of wood that we used. Oh gosh, we didn't run that much. I don't know. 1/8 of a cord, maybe. We didn't use hardly any wood whatsoever. We've got aspen trees on the property that fall down all the time, so we use that to burn. Okay, so here's the last couple that I'll show of this. So what you end up having is, this is that detail that I went over before, where I'm connecting into my chimney pipe. And I know everything that above me is nice and sealed up. Okay. Then what I've got, the way that it just spaced out, is you've got this little stub of metal right here. That's a little double wall chimney pipe. And then this piece right here, from the top of the stove to right here, is a telescoping joint. And if I zoom in, that is what it looks like. So that telescopes this bottom piece of it and push up into this upper piece, and then you can drop it back down and it can sit up on your stove. So think about, like, let's say you want to clean your chimney, right? This telescoping joint would be really easy. You come in to clean your chimney, you unhook the screws right here, you just push the bottom part of the telescoping joint up, put a little bucket underneath there, run your brush right up, your chimney, and you can clean it from the inside, and all your soot and everything falls down into the bucket on the inside, as opposed to having to climb up on top of the roof and try to clean it. So knowing that, I wanted to keep this joint mobile. Now this joint right here and this little joint right here, I just put black high temperature silicone around it. Like I said, I'm comfortable doing that because the same black high temperature silicone was used and recommended by the manufacturer to attach stuff to the backside of this stove. So this joint is sealed, that joint is sealed. So how do I maintain without pumping this thing full of silicone? Which I could do, and then have to, pull it out at the end of the day whenever I want to go clean this thing. How do I keep that mobile, but also keep it airtight? So here's what I came up with. It worked. At least I think it worked. You've got this collar. So they sell this collar. It's like a $8 collar. It's just decorative and it's meant to cover up joints that you have. Okay. So I've got a collar. St. Gobain, I can't remember. Let me know if you're really interested in it. St. Gobain makes a foam product that has a 500-degree Fahrenheit sealant on it. And the foam that is in this gasket is good to up to 500 degrees as well. So what I did is I put 2 strips on the top and bottom of this collar, so that when I took that collar and then wrapped it around this joint, the top seal would hit the top part of the telescoping joint, and then the bottom seal would seal against this bottom part of the telescoping joint, and it was just held together with a screw. So I could just back that screw off whenever I need to clean it, pull this collar off, lift my telescoping joint up, clean my chimney from the inside, drop it back down, and then attach this collar back in place. Okay. Now here's why I say it worked. This was during the blower door test, and this is I think FLIR Pro, one of the cameras that you add onto you put it on your iPhone. It's not the lowest version, it's the next version up. So this is while we were depressurizing the house. It was probably, I don't know, 25 degrees outside. So we're sucking air. We're trying to suck as much air as we possibly can into the house when I took this picture, and I see nothing along this collar indicating that I'm sucking cold air in across that. What I did notice, and you could definitely feel it, even though this was, an airtight stove and, a high quality stove, there were small little gaps down where the panels of the stove were put together that you could feel a little bit of air. But I mean, this was in place when we did our final blower door and we hit 0.14 ACH50. So yes, there was air coming through there, but it wasn't very much. And I'm not too concerned with that. Now, one thing we'll do, if we go back to this combustion air, like you got during the winter when you're running this thing, this is sucking in air from the outside. So it's really cold air, potentially. I mean, you're -5 degrees or whatever that is. So this will have a larger metal cover to it that will be insulated so that you don't have any risk of condensation or anything because you've got, 5-degree air or something like that coming through this tube. So that's something that will be put into place too. Okay, so that's a 22-minute explanation on how we install our wood stove. Let's see, how many people do we have sitting around? 15? That's not too bad. Let me see here. I will. Andrew, sorry, man. Andrew, sorry. I just saw that you were in the waiting room. I don't know how long you've been there. Okay. Whoops. I didn't mean to unmute everyone. You don't know. Okay, cool. You guys are able to unmute yourselves. We don't have that many people in here, so if anyone had any other questions or anything, I'm more than welcome to answer it. If not, I'll set something up in the next couple weeks, and then we can go over additional framing details and whatnot for the rest of the project. Cool.
Thanks, Tully. Have a great one.
Yeah, you bet. Thanks a lot. Cool. Okay, guys. Well, if no one has anything, like I said, let me know. And if you're interested in that second round of it, and if I don't have your contact info, then we'll get it. And yeah, we'll talk to you guys in a couple weeks. Thanks, everyone. Appreciate it. Have fun.
That was
Reach
great.
out
Thanks very
anytime
much.
over email or Instagram or whatnot. I'm here to help. What's up, Andrew? Sorry, man. I don't know how long you were in the waiting room, but all right. All right, everyone.